So I want to bring up one question that allows me to kind of preview some of the important facts about synapses that we'll study as we open up the topic of neurotransmitters next week. So we know that the synapse is that connection point between the terminal button of one neuron and the dendrites of another. And it allows, so when an action potential has fired and traveled all the way down the axon, right at the connection point between two neurons, that message is no longer traveling electrically. It has to travel chemically. Neurotransmitters have to pass through the gap between cells and influence whether the next cell in the chain of communication is likely to fire in a chemical synapse, which is the type that we're studying in this course. And I want to, just for our last couple moments, I want to talk about a really important question, and we might talk about this a bit more next time if we don't discuss it thoroughly now. The question is, this comes from Karen, and Karen asks, does exposure to experiences, environmental ones or social ones, do our life events, what we go through, change our perception of either topics or situations? So what do you guys think? Do our experiences change our perception, change the way we think? Yes or no? Good answer. I see a yes. I think most people would agree that, yeah, of course, as you go through life, your experiences change the way you think, they change how you perceive things. I mean, you can see this all around you. Have you ever had the experience where you didn't know a word, and then one day you learn this piece of vocabulary, whether it's a scientific term or a new hashtag that popped up on TikTok? And then after you've learned it, it seems like it's everywhere. And that's just because your brain recognizes it now and you're seeing it when you didn't before. Our everyday experiences dramatically change how the nervous system functions. Without the nervous system changing based on experience, we wouldn't be able to learn, we wouldn't be able to change as people. So our nervous system has an incredible power to constantly adapt to new experiences. And it does this through its plasticity. So what do neuroscientists mean when we say the brain is plastic? You guys are familiar with my little plastic brain model. That's not what we mean. The brain's not made of plastic. When we say it's plastic, we mean that it can change based on experience. And that is really what is at the heart of learning, is your neurons actually changing their wiring structure based on new experiences. And it was this fact, the fact that neurons physically grow and change based on what happens to us in our everyday lives, that made me so excited to study neuroscience. I remember I was in brain and behavior back in 1998, because I'm old, and I was sitting in class and I learned about the work of Eric Kandel. He's a Nobel Prize winning neuroscientist, and he studied the sea slug. It's really popular for neuroscientists to study the sea slug because it only has like 300 neurons. So it's kind of easy to see what's going on inside that creature. And the sea slug has a natural reflex. When you squirt it with water, it kind of contracts to protect itself. And what Kandel noticed is that the neurons that sent the message commanding the sea slug to contract, that it was a small chain of connected neurons that one triggered the other with this combination of electrical and chemical communication we've been studying. That chain got more connected. Those neurons actually grew more terminal buttons and more dendrites, allowing them to communicate much more efficiently. Those neurons that were frequently stimulated together listened to each other in a more powerful way. And I was kind of mind blown, realizing that inside my brain, based on what I go through in a given day, my neurons are actually growing new connections to become better at thinking the thoughts that I practice thinking, and to become better at producing the behaviors that I practice behaving. I was totally like wowed by this fact. And this is really one of the most powerful messages that I have to share with you in this course, And neuroscientists have a nickname for this plasticity, the power of the brain to change over time based on the structure of the synapse changing. They say neurons that fire together wire together. And I'm going to show you what that looks like.
So what's going on in this image? We have a neuron that I've nicknamed neuron A, and it is sending an action potential. It's sending a message down the axon, and that action potential causes its terminal buttons to release neurotransmitter. Now, neuron A is in the position to potentially influence two other neurons that are listening to it. They're downstream in the flow of information within the brain. This neuron that I haven't named, as you can see, has a really small connection to neuron A. So it's only getting a little bit of neurotransmitter for each action potential that neuron A fires off. Therefore, the influence of neuron A in this case is not enough to make our unnamed neuron fire its own action potential. So the message doesn't travel from neuron A to mystery neuron, which we're going to now ignore. Something different is going on in the top half of the image. You can see that when neuron A fires an action potential, there's more connection physically between neuron A and neuron B. More terminal buttons of neuron A are connecting with more dendrites from neuron B. So this results in neuron A's action potential exciting neuron B a little bit more. And this wave of excitation in the case of neuron B is enough to trigger neuron B to fire its own action potential. So these neurons are firing together in the sense that they're setting each other off. And this is happening in your brain all the time. So neuron A and neuron B are firing together repeatedly. And that causes a physiological change in these neurons over time. So when you practice something over and over again, whether it's a physical skill like your brain signaling the perfect hand moves to flip an omelet, or a thought you think repeatedly, which could be memorizing someone's phone number, or a mantra that you like to repeat to help manage your mood. Anything you practice causes neurons to fire together. And when they do, they wire together. And what that looks like is visible in this aftershot. So before learning, you saw that there was a moderate connection between neuron A and neuron B, and A could influence B. But look what happens after repeatedly firing together. Neuron A and neuron B have actually grown more connections. So more terminal buttons have sprouted on neuron A. It's like, it's been taking hair growth vitamins and there's terminal buttons everywhere. Meanwhile, neuron B has physically grown new dendrites, like a tree growing new branches, so that it can soak up more neurotransmitter from neuron A when it sends a message. So the physical connection between these two neurons, which represent, your ability to do a certain action or think a certain thought, has actually become stronger, more responsive. And this is how your brain physically changes based on what you practice in your everyday life.
So your brain is constantly being reshaped by your experiences physically. And that's at the heart of learning. And, we think of learning as this really positive thing where we learn and grow over time. And sure, it usually is. It often can be. It's brain plasticity, it's neurons that fire together, wiring together, that allows a baby to learn to speak or a toddler to become potty trained. But our brain can also be changed in negative ways by experience. When a certain neural pathway is stimulated over and over again by an illicit drug, for instance, that chain of connected neurons actually becomes more sensitive to each other, making the brain more sensitive to the drug. And that physical change in the brain of a frequent drug user underlies the pain of addiction. We know that a traumatic experience can make the fear circuit more powerfully wired. The physical connection between the nerves actually becomes more powerful. Neurons between the amygdala and hypothalamus grow more dendrites, grow more terminal buttons, get juicier connections. And that can make us temporarily oversensitive to new threats. That's how trauma physically reshapes your brain. That's another example of learning. So, this idea That nerve cells that fire together grow these juicier, thicker connections and share more neurotransmitter is underneath practically every change in the human brain that we want to understand. So it's plasticity, the ability of a chemical synapse, like what we're studying, to grow new connections that allows us to be shaped by our experiences for good or for worse. I found that super mind blowing, and I hope you find it fascinating too.